Okay guys, what we're going to look at now is you've learned to draw Lewis structures and you've practiced with some on your assignment, but we're going to go back and what we've got to look at is the structure that you've drawn may or may not be correct. So what we're going to do is we're going to use something called formal charges. And I've kind of moved my notes around in this program so I can kind of work with them. So this is not page 1 of your notes. It is on a different page. So just kind of look through there and go back to the spot where it says correcting Lewis structures using formal charges. So what you have to understand at this point is not all structures are going to have an octet around them. There can actually be more than an octet. There's a lot of structures out there that don't obey that octet rule. So you're going to see some that have more than 8 around it, and it's fine as long as we look at this formal charge and everything is okay with it. So this is just a type of bookkeeping that you do to make sure that you've drawn a structure correctly. So what I kind of tell you here is if you've got an ion, it needs to match the charge of the ion. So if I am dealing with sulfate, my formal charge is going to match that 2-. If I'm dealing with a compound, well, compounds are neutral. So if I have CO2, that's just going to be 0. The charge on any compound is 0. So all formal charges of every single atom in the compound will end up being 0. So here's the rules on how you kind of work through and figure out the formal charge. It's going to make more sense when we actually see one. So what it says in step 1 is all unshared electrons are going to be assigned to the atom on which they're found. So for example, I'm going to just kind of work a partial molecule. Say we've got this and we've got 6 electrons around that oxygen atom. So all those dots around oxygen, those 6 electrons, those unshared electrons, they all belong to oxygen. And then step 2 says for any bond, single, double, or triple, half the electrons are assigned to that atom. So I'm going to use a different color. What you need to think about is on that dash, 1 electron on that end belongs to carbon and the other end belongs to oxygen. So if I'm looking at total number of electrons that are assigned to that oxygen right now, there's 2, 4, 6 unshared and then 1 shared. So right now it has 7 electrons that are assigned to it. And I can't draw that 7. And then if I look at the number of valence electrons that an oxygen atom has, if I look up what column it's in, it has 6 valence. So right now I would say that that oxygen is sitting at a 1- formal charge. And if this is a compound and I need it to be 0, that means I've got some kind of an issue that I'm going to have to fix. And that's what I'm going to kind of show you as we go through here. Some other helpful hints they tell you about formal charges and structures is the dominant structure is the one where the atoms have charges closest to 0. They may not all be 0, like in the case of sulfate up here. It's not going to be 0. It's going to be 2-, but I'm going to try to get it as close to 0 as I can. And then a Lewis structure, if there's negative charges on it, the more electronegative atom is going to be your dominant one. I'm going to show you that with letter B down at the bottom there. So we're going to work these 2 problems, and then we're going to go back to just a few of your structures, and we're going to kind of look at them and see, did I draw them correctly or didn't I? And we'll kind of fix a few of them that need to be fixed. So we're going to do carbon dioxide first. So carbon has 4 valence electrons. There's 2 oxygen, so that would be 2 times 6. So there's going to be 16 electrons on this picture. So I'm going to start out just like I did in the last video. You still have to follow those rules on how you put that structure together. So again, carbon's going to be your central atom, and it's going to be, you connect them with the single dash first. So I've got 4 electrons on my picture. So then I'm going to have to say there's 6, there's 8, there's 10, there's 12, there's 14, and there's my 16 electrons. So at this point, instead of like maybe you forgot the steps on how to put the structure together, but you remember formal charges. If I wanted to look at formal charges of the atoms here to see what I need to do, let's take a look at the oxygen atoms. Again, it's like the one that I did up above. I see 6 unshared electrons around each of those oxygens, and then I see them in a bond. That means if I follow the rules here, it has 7 electrons assigned to it. But again, an oxygen atom has 6 valence. So these oxygen atoms, my pen is not working very well tonight, are both sitting at a -1. So that's telling me that something's wrong here because carbon dioxide is a molecule. It's a compound. So all those should be 0. Now, if I take a look at carbon, it's got 2 bonds that it's in. So it technically only has 2 electrons assigned to it right now. And if you look up carbon, it has 4 valence. So carbon is sitting at 2+ right now. So the only way that I can fix this to get those formal charges down to 0 is to erase pairs of electrons and make either double or triple bonds. And you can kind of see how that's going to change the formal charge. So what I'm going to do is I'm going to look at the oxygen on the right. I'm going to take this pair of electrons off the top of it. And what I'm going to do is I'm going to go back and I'm going to make that a double bond. I'm going to look at how that adjusts the formal charge. So now if you look at that oxygen atom, it has 4 unshared electrons and then it's in 2 bonds. So technically it has now 6 electrons assigned to it and it has 6 valence. So what I've done is I've knocked that formal charge down to 0. And if you look at carbon, carbon is now in 3 bonds, meaning it has 3 electrons assigned to it. So it's now sitting at 1+. So you can kind of see now what I need to do. I need to erase another pair of electrons, but I need to do this on the other oxygen atom. So I'm going to erase them from the top. I'm going to erase that pair right there. I'm going to go back. I'm going to make that a double bond. And then if you look at it, what I've done is I've knocked this down to 6. So I've made that now 0. And if you look at carbon, it's in 4 bonds now. So it's 0. So now that I have a compound, every single one of those is knocked down to 0. So that means that this is correct at this point. So for the next one, I'm going to try to do this in a different color so it doesn't mix with the other one. So I've got nitrogen, which has 5 valence. I've got carbon, which has 4. I've got oxygen, which is 6. And then I've got to add 1 more for that electron that it's gained. So now I'm looking at 16 electrons on the picture. So I'm going to say carbon is in the middle because it is the least electronegative. So I've got a nitrogen, a carbon, and an oxygen. That's 4 electrons. So there's my 6, 8, 10, 12, 14, and 16. So all my electrons are on the picture. I'm going to go ahead and look at getting formal charges to see what do I need to do here? Do I need a double bond? Do I need a triple bond? Do I just need a single bond? So let's look at the oxygen. It actually looks like the one that I've done several times. It's got 6 unshared electrons and then it's in a bond. So that means that oxygen atom is sitting at 1-. If I look at carbon, it has no lone pairs. It's got 2 electrons assigned to it, but it has 4 valence. So that is sitting at 2+ right now. And then if I look at the nitrogen atom, it has 2, 4, 6, and then 1 bonding electron. So it has 7 assigned to it. But a nitrogen atom, if you look it up on the periodic table, only has 5 valence. So 5 minus 7 is, it's sitting at 2+ right now. Now remember, this is an ion. So I'm going over here. This does need to have a 1- charge. So if you look up at the top, it says, oh, where did it go? Right here. So a Lewis structure in which there's going to be a negative charge, it needs to be on the electron or the atom that's more electronegative. So if I look this up, this is, if you look at left to right on the periodic table, that trend, oxygen is your most electronegative element. So that oxygen that has the 1- formal charge, that needs to stay. So nothing needs to happen between carbon and oxygen. But what you need to look at is the 2+. Oh, am I wrong on that? I think I'm wrong on that. That's 2-. I'm wrong on nitrogen because it would be 5 valence minus, or 5 valence minus 7 assigned. So that guy I have wrong. So let's erase it and fix it so I don't confuse you guys any further. So that should be, you guys know me, I do this in class. I always mess up when I'm talking. So that one's 2-. So if you think about this, if you erase 2 pairs from nitrogen, then you're going to get those both knocked down to 0. So what I'm going to do is I'm going to erase a pair of 2 pairs of electrons from the top of nitrogen, if I can get it to work, top of nitrogen and bottom of nitrogen, and erase part of nitrogen. This pen is a pain in the butt to deal with, but I'm trying my best. So then I've got a double bond and then I've got a triple bond. And if you look at it now, carbon has, it has 4 bonds around it, meaning it has 4 assigned to it. So it is now knocked the formal charge down to 0. And if I look at nitrogen, it's in 3 bonds and then it has 2. That would knock this number down to 5, which would make my formal charge 0. So my 1- charge, because of the charge of the ion, that is the correct way to draw that structure. So now what we're going to do is at the bottom of this page, it says, go back, we're going to correct your structures. Some of them may be right. Some of them may be wrong and you just have to fix them. So we're going to look at that, and then I'm just going to work a couple on here, and then I'll have a separate video if you guys need to go and get more practice or even just check your work from the notes. I'm just going to work a few right now. So the first one I'm going to look at is this PBR3. So I redrew this to kind of, so it may not look exactly the same as what it did before, but you guys may not even notice. So I redrew it. So we got to let's look at the bromine atoms because they're all the same. So to look at formal charges, what I want to make sure is this is a compound. Every single one of those elements should have a formal charge of 0. So if I look at bromine, it's got 2, 4, 6. It's got 6 electrons that are unshared, and then it's in one bond. That means it's got 7 electrons that are assigned to it, and a bromine atom has 7 valence electrons. So each one of these is sitting at 0. So that's a good sign that you probably have this drawn correctly. But I got to double check that central atom, that phosphorus. So it's got the 2 electrons on top of it that go to it, and then it's in 3 bonds. So 3, 4, 5. And if you look at phosphorus, it has 5 valence electrons. So that means you have a structure that's drawn correctly. If your formal charge is all balanced to 0, then you're good. All right, the next one we're going to look at is the CH2Cl2. So when we look at this, let's start with the chlorine atoms. So if I look at chlorine, they've got 2, 4, 6, and then 1 bond. So they've got 7 assigned to them, and they each have 7 valence electrons. So those are 0. So when I look at hydrogen, as long as I know that hydrogen's in a bond, that means it's got 1 assigned to it and it has 1 valence. So as long as you see hydrogen in a bond, it's good. So we just need to check the central atom, but I see 4 bonds and it has 4 valence. So that would be 0. So that structure is drawn correctly. So now we need to move down to the ions, and we're going to look at some of these. So these are the ones that there are going to be issues with a couple of these. So I didn't draw the brackets so I could save room. I'm going to redraw this structure to kind of fix it. So I left the brackets off right now. But when I look at this bromate ion, let's first take a look at the oxygen, because if I figure out one, again, I figured out all of them. So again, it's got 2, 4, 6, and then that 1 bonding electron around them. That's 7 assigned. So that means because it only has 6 valence, each one of these is sitting at a formal charge of 1 minus right now. So that's kind of telling me something's up, because I am going to have a negative charge, but only -1. And I want to get as many of them to 0 as I can. So like if I look at the bromine atom, it's in 3 bonds, and then the 2 left over on top, that's only 5. 5 assigned, but bromine has 7 valence. So that bromine atom is 2+. So what I think about here is I want to try to get the bromine down to 0. So I need to fix, I think because it's 2+, I need to get it down to 0. I need 2 different things to happen here, meaning I need to take some of those lone pairs and make them bonds. So let's just look at the atom, the oxygen atom on the right. What I'm going to have to do is, the only way that I can fix this is to erase a pair of electrons and then go back and make that a double bond. And if you look at how it affects that formal charge, what it did is it knocked that atom down to 0 now, because it's got 6 assigned to it, which matches its valence. As long as it matches its valence, it's fine. And then if you look at what it did to the bromine, it added another bonding electron, so it now has 6 around it, but it needs 7. So it knocked it down to 1+. So I just need to do that one more time. So what I'm going to do is I'm going to look at the oxygen on the bottom. I'm going to erase the pair at the bottom. Then I'm going to go back and I'm going to make that a double bond. And then what it did was it knocked this down to 0, and it now knocked bromine down to 0, because now bromine has 7 assigned to it. But what I want to point out here, and this is the correct way to draw it, I'm going to redraw it over here. I'll do this in green. So I've got a bromine, double bonded to oxygen here, and then a single bond. So this would be the correct structure that I would be looking for on a test. You show brackets, and there's still that lone pair up there, and this is 1 minus. But what I want to point out is this is definitely a molecule that disobeys the octet rule. If you look at the molecule up here, carbon has 8, if you're talking total electrons around it, because it's in 4 bonds, that's 8 electrons floating around it. So that one is obeying the octet. But if you look down below, if you think about how many total electrons are around bromine right now, each bond, remember, is 2 electrons. So it's got 1, 2, 3, 4, 5 bonds around it. That's times 2. That's 10 electrons plus the 2 on top. That's 12 electrons that are around bromine. So this definitely is disobeying the octet rule, but by formal charge, this is correct. So when you look at it, yes, the octet rule is important, but formal charge kind of trumps that, and it's more important. So you do have to make sure that you have that structure drawn correctly for formal charges. Okay, and the last one we're going to look at is this chlorite ion. So this should be how you have it drawn. Again, I don't have the brackets. We are going to fix it. So let's look at the oxygen atoms. Again, they've got 6 electrons plus the 1 bond, so it's kind of been the same each time. That means each one of them is sitting at 1 minus. And somehow my pen just does not want to work for me. The chlorine is in 2 bonds. That's only 2 electrons. So, and then 3, 4, 5, 6. Again, 6 assigned, but a chlorine atom has 7 valence. So it's sitting at a 1 plus. So I do need this to have the 1 minus charge because the chlorite ion has a 1 minus charge. So what I'm going to have to do is I'm going to have a double bond between one of them. I'm just going to pick the one on the right. And what I'm going to do is I'm going to erase a pair of electrons at the top. And then I'm going to go back and I'm going to make that double bond. And then I'm going to kind of look at that formal charge because of that. So what I did with the oxygen on the right is it now has 6 around it, 6 assigned. So it's knocked that formal charge down. If you look at chlorine, it's got 1, 2, 3, 4, 5, 6, 7 around it. So it's knocked it down to 0. So again, that 1 minus charge is going to stay on that one because of the 1 minus charge on the molecule. So my correct structure over here should be an oxygen single bonded to chlorine, which is, a single oxygen bond between that oxygen and chlorine, and then a double bond here. That one has 2 pairs of electrons. This one has 3 pairs of electrons, and there's still those lone pairs on chlorine. And again, if you look at this, if you think about how many electrons are total around chlorine, it's got 3 bonds. So technically that would be 6 electrons. And then it's got those 2 lone pairs. So it's technically has 10 electrons around it. So this one is disobeying the octet rule because it has more than 8. But by formal charge, this is drawn correctly. All right, I have one last thing that I'm going to go over with you really quick. I'm not actually going to work this one up here. I'm going to work letter A down here. I just want you to kind of have an understanding of what a resonance structure is. So really what it means is just two or more valid ways that a Lewis structure can be drawn. So I'm going to draw the first way. This is how we drew carbonate when we drew this earlier in your notes. We had it drawn like this. So this one had the 3 pairs of electrons on it, and then this one just had the 2. And then you've got that carbon atom in the middle. If you take a look at this though, why did I decide to put the double bond on that oxygen atom? So what a resonance structure is, it's just a different way that you can draw this structure. So that's one way that I could draw it, but a resonance structure, another valid way to draw this would be, I could have put that double bond at the bottom. I could make it here. And then this one would look like this. And then this one would look like that. So that's a resonance structure for carbonate. And then actually there's one last way that you could draw this, one other way, and I'm going to kind of move down here so I have room. The double bond could have actually been over here. And those could have been the single bonds. So again, they're all valid structures. They're just different ways to draw it. Sometimes there could be 3 like mine, there could be 4, there could be 5, there could be 6. It just depends on how many different ways you could draw it, how many different places you could put that double or triple bond. So when you see a question that says draw all the resonance structures for this, that's all they mean. Just look at the different ways that it could be drawn. So that's kind of the end of this. We have one last piece dealing with the Vesper theory that I will make another video for. I have a video of the rest of these practice problems in this worked out, but as of now, you can go back and finish that Lewis structure assignment and finish all of part 2, pretty much finish the entire assignment, and then submit it to me so I can look through it and make sure you guys are doing these correct. If you have any questions, please email me.